All right. So, the counter equation part 1. Here we're going to get into the basis of the formula, which really is the angles. So, we start with, as part of our givens, we have the interior angles and their order going clockwise. Okay? To get, really what we want is phi, or the angle relative to the positive x-axis. The positive x-axis, very simply, this would be 0 degrees. You see how it's the x-axis, it's horizontal, and it's heading in the positive direction, where 0 degrees is just a flat line. All right, so this is 45 degrees, this is 90 degrees. Don't mind the drawing, you can hear what I'm saying. All right, I'm in a hurry. So, we can start out by saying with any polygon, right? Phi 1 is going to equal theta 1, all right? That's the same for, any polygon you're gonna apply this formula to. This is your starting point. But beyond that, of course, we need a way to figure out what the next phi's are. And so we have this equation. Phi n equals phi n minus 1. All this means is the previous phi plus 180 degrees plus theta n, the interior angle. Okay? Now, this is all well and good, but you're probably wondering, Billy, how do I know you're not full of poop? Okay? I will prove this. I'm going to do the short proof for part 1. The part 2, I'll do the long kind of brute force proof, because the short proof, it's nice and short, but it's a little bit involved, maybe just a little bit. So, short proof, right? We have our phi n minus 1 here. Fundamentally, I drew it like this. It doesn't matter where it's going, okay? Let me draw. So this is the x-axis. This is also the x-axis. It is simply just elevated up. So you could think of it as the x-axis elevated up, or a line parallel to the x-axis, whatever. It all works. And we want to know, I don't know. That's the next side. We gotta get that angle relative to the x-axis. All right? So fundamentally, with any side, right, this is phi n minus 1 degrees, right? Going here, so even here, all right? We're gonna start with phi n minus 1 from 0 degrees, right? You see how it stays the same because these two lines are parallel, all right? We haven't changed anything. We're gonna now add 180 degrees. That's gonna get us here, all right? By the way, this big angle here, that is theta n, all right? Now, so we've gone from here, phi n minus 1, 180 degrees, bam, now we're here. If we add theta n, you can clearly see we end up here, which is where we want to be. So we started at the starting point, which is 0 degrees relative to the positive x-axis, and then we ended here. That means that after we add all this up, we're going to end up with phi n, which is the angle relative to the positive x-axis, which is what we want and what we need. Now, I'm going to include a second kind of example for everyone to imagine it. All right, so we just have our line, right? Again, phi n minus 1. Fundamentally, I'll do this here, and then, I don't know, there. That's the next one, all right? So fundamentally, you could imagine we're just flipping it over. And flipping it over orientates it in a way where all we have to do is add the interior angle. Now, what can be confusing, and this is why I'm doing this example specifically, is sometimes it can get confusing if someone tries to say, oh, in this scenario, what would you do if this is the next angle. They might not realize this is impossible, all right? Or this is incorrect, at least. This is actually the exterior angle, all right? And we know this, we can know this. So this is totally incorrect and improper. The correct angle, this is very important. It is always, so you have, let's say this is SLK minus 1, and the next side is SLK, all right? We're going in order, all right? Something we're always going to do is when we add the angle, we're not going to go clockwise. When you add angles, what do? You always go counterclockwise when inputting an angle. That's how we regularly use angles, right? Maybe if you're saying a negative angle, then that's going clockwise. But so we need to be going from SLK minus 1 to SLK. We need to be going, theta is the interior angle, is going to be going counterclockwise, not clockwise. That's just a point of confusion that some people may have, right? They say, oh, what about this? Oh, it doesn't work for this. No, you're not setting it up correctly, all right? Of course, the reason why, I guess I have to get in why I know that. Why do I know that it has to be a certain way? So fundamentally, we are going clockwise around the polygon, okay? There's just an example polygon I have here. You go from this side to this side, all right? That's the key point. From this side to this side is clockwise, okay? So around the polygon, we're going clockwise, but of course, when we add the angle, we're going counterclockwise, okay? So from here to here, we're going clockwise this way, but from here to here, we're going counterclockwise. You see that? If we were to go clockwise, we would get the exterior angle. And that's the same around the polygon, all right? I'll tell you what, I can maybe show it more in depth at a later time, okay? It's kind of involved. There may be some people thinking, oh, I can think of an example where that's not the case. You're wrong, okay? This is always true, trust me. I might, if there's enough demand, I'll do another video showing why it's always true. So in this case, it's the same, right? We have our line here. It's going this way. We're gonna flip it, 180 degrees. Now it's like we could kind of imagine it's going this way. And we're simply gonna add the angle right here that connects these two sides. And then bam, we have this. You see this? That's what we get. We started at, this is very important, we started at 0 degrees, all right? So like we start at 0 and then we add phi n minus 1. So you could imagine, oh, we start at 0 and we add it. Or you could just imagine we start with phi n minus 1. Same thing, right? I guess for this, it's more helpful to imagine it. We're starting at phi n minus 1. 180 degrees, we flip over, and then all that's left. For any, it doesn't matter, it could be going this direction. Oh, that's almost a straight line. It could be going, sorry about that, it could be going this direction. It would be just a shorter angle. Theta would simply be shorter. It could be going this direction. Theta would be a lot bigger. All right? Whatever is required, all right, whatever the interior angle is, you just simply add it. And I hope that shows why this formula is always correct. We can always use this to convert from the interior angles, which are reasonable givens, into the angles relative to the positive x direction. All right, the positive x axis. All right? Yeah, I think that's pretty good. And on the next video, I'll do the brute force proof for anyone that has doubts on this. Although I think it should be pretty good. I'll see you then.